Okay, so I left off on when I was talking about this minus 1.32. So if I want to calculate that, I go to the z table of negative number and I go minus 1.32, which the probability linked to that is 0.0934. So 0.0934. So that is the probability of this yellow area of the lower spec limit. So now, using this z of the upper spec limit and z of the lower spec limit, I was able to calculate this probability. Now, what is the overall probability of this process? So the temptation is that people will add this to sea level and then they will say that's the total sea level. But in these type of calculations, you never add z level, but instead you add probabilities. So we're going to say, okay, if this is the probability of the effect of the upper spec limit, this one is the lower spec limit, I'm going to add them to know what is the probability of the effects overall. So in this case, if I add those two, I'm going to have a 0.138 probability of defect of both the upper spec limit and the lower spec limit. So what is this total z level? Well, again, just like I did before, and knowing that the table is going to give me the opposite side, I'm going to do 1 minus that number, and that's going to give me a 0.862. So where is that located? So I can know what is the sea level associated with that. So I will need to look in the table and find that probability of 0.862, which in this case is, if I look at the table, you see 1.09 will give me 1.09 will give me that 0.8621, which is the probability that I found. So therefore, the z level is going to be 1.09. So that is going to be the total z level of this process. So if somebody says, okay, what is the overall z level, then I will say 1.09. Remember, this is because we have both upper and lower spec limit. If I don't have a lower spec limit, then my total z level will be 1.7, right? Because I wouldn't have to worry about the lower spec limit. Now, finally, let me just show you how I will use that information. So then I can use that to say, well, now how capable is my process? Well, if you are planning to produce 30,000 items in a year, let's say of that report, how many defects you will predict you will have above 25 and below 10. Because we calculated the overall probability, which is 0.138, all I do is use that probability times the the production volume that I'm going to do on that process, and that's going to give me 4,200 reports I know or I predict are going to be either above 25 or below 10, which are defects. Then I can make the right decisions as to whether or not this is the right process, if whether or not I need to improve the process, because now I know how capable this is. I also added here how to do the same calculations using Excel without using the tables. I'm not going to walk you through in this video, but I'm going to leave a copy of this file in the team site, so that way you can figure out what are some of the formulas that I use in case you want to use formulas to estimate those probabilities. So I hope this was helpful. I hope this will help you to better understand this idea. If you practice a couple times, if you do two exercises, you're gonna start getting used to and understanding how to estimate this type of probabilities and the capacity of your process. Thank you, guys. and I will keep recording some of these short videos. Bye bye.